Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework again tonight. We're looking in Math 1, Worksheet 5.2. Remember that every problem on this homework help mirrors the exact problem on your homework. So if you're having a problem with a particular homework, fast forward to that homework and we should be able to help you out. Let's get started. Our first problem simply asks us to simplify the expressions. The first one says 3 to the minus fourth. Very important that you realize that when you have a negative exponent, it has absolutely nothing whatsoever to do with a negative number. Remember that if you have 3 to the fourth, that means 3 times 3 times 3 times 3. You're going to multiply 3 by itself 4 times. That's what that means. Now, what's the opposite of multiplying? Well, the opposite is dividing. So when I say 3 to the minus 4, what I mean is 1 divided by 3 times 1 divided by 3. Or in other words, this is 3 to the 4 is 1 over 3 to the 4. One way we treat this is the first step, step 1, take the reciprocal, okay? So the reciprocal is 1 over 3, and then change to positive. In other words, change the minus 4 to positive 4. So the answer for the first one is 1 over 3 to the 4, and then if we calculate that out, that is 1 over 3 times 3 times 3 times 3, which is 1 over 81. Now the next one, x to the 0 power, absolutely always any number to the 0 power equals 1. Okay? Any number. The only exception is x equals 0. But other than that, any number to the 0 power is always 1. For number 3, let's break it down into our factors. Remember that these factors, this is 7 times m to the third times n to the minus 1. The only one we want to change is we want to change this one because it has a negative exponent. We don't want to leave that with a negative exponent. The others are fine. So we'll leave them alone, 7 times n to the 3. And then remember the rule here, take the reciprocal. So this is 1 over n, and then change the negative to positive. All right? So now I can complete this, multiplying them all together, and my answer is 7 m to the third, and then my n goes down on the bottom. Notice I don't need to put the 1 again. That's redundant. N to the 1, n to the same thing. But again, remember, with a negative exponent, take the reciprocal of n, so 1 over n, and then change the negative 1 to positive 1. All right? Now, similar here with number 4, let's break this down into its factors. I have 5 times 1 over x to the minus 4. All right? So the 5 is fine. But what's the reciprocal now of 1 over x? The reciprocal of 1 over x is x over 1, and now I change this to 4. All right? So my answer is 5x to the 4th. One thing to notice is that when I had n to the minus 1, it caused it to go down and become 1 over n to the 1. Here, I had 1 over x to the minus 4, and the reciprocal causes it to go up and become x to the 4. So a common thing, you just think reciprocal, or you think moving from numerator to denominator, or moving denominator to numerator, and then changing it from negative to positive. Now there's a couple ways to work number 5. I'm going to show you the long way, then the short way. I could, by our definition of exponents, I could change this to 5 to the minus 2 over 7 to the minus 2. And then I could write that as factors as 5 to the minus 2 times 1 over 7 to the minus 2. And then using our rule, change this and take the exponent and then change the reciprocal and then change it to positive exponent. That goes down. whereas this one's on the bottom, so it's going to go up. So I'm going to have times 7 squared. And so I would end up with 7 squared over 5 squared, which would be 49 over 25 would be my answer. Now, there is a much simpler way than doing that. Remember we said just take the exponent. So if I take 5 over 7 minus 2, what is the reciprocal? The reciprocal is 7 over 5, and then change it squared. And then you see we get the same thing, 49 over 25, 7 squared. Okay? Now, we'll apply that to number 6 to make it even easier. First step, do the reciprocal, 4n over 3m, and then change that to cubed. Now, when you take the power of this, everything gets the cube. In other words, this is 4 cubed, n cubed, 3 cubed, m cubed. So 4 times 4 times 4, 4 times 4 is 16, times 4 is going to be 64, n cubed, and then 3 times 3 is 9 times 3 is 27, m cubed, and there's our simplification. Number 7, once again, I'm going to split them into factors just so you don't get confused. I have 7 minus 2 times q to the 4th times r to the minus 7th. Now to simplify it, all I need to do is take care of the ones that are negative. So here's a 7 to the minus 2, so I change that to 1 over 7 to the positive 2. The q is fine, it's already positive. The r then is 1 over r to the 7th, positive 7th. Now if I put these all together again, I'm going to have the q4 on top divided by the 7 squared r 7th. Now I can simplify my constant, so my final answer is q to the 4th over 49 r to the 7th. Okay? So let's break the 8 down. Here's my factors. And now, I'm not going to do the factors so much. You should know that this is 13. Let's just take them one at a time. First, 13. 13 is going to stay right where it's at. Okay? X to the 0, any number to the 0 power is 1. So that's going to be 1. Y is okay, so we'll leave y alone. Z to the minus 1 goes down. All right? So it goes down below to the 1 power. And now v to the minus 2, the reciprocal moves it up, so it's going to be up here at v squared. So our final answer then, 13 times 1 is 13y v squared over z. Notice the pattern. If you see a negative in the top, just send it down. If you see a negative in the bottom, send it up, and also change the exponent from negative to positive. All right, so let's get started on this one. I'm just going to make a line here, start bringing them down. First, I got my 4. Don't need to change anything there. Here I have my m to the minus 1, so that's going to be 1 over m. In other words, I bring the m down and change it to positive 1. Now let's go down below. We've got a 7. I'm going to put it out here because I always put the coefficients in the first. Then I have ab to the minus 3rd. So I'm going to move that up here. Notice it's parentheses. Everything is there to 3rd. C to the 5th stays right where it is. Okay? So now let's put them all together. The only thing I have to do here is realize that this is AB. Notice that AB to the 3rd would be AB times AB times AB, which would be A to the 3rd, B to the 3rd. So we end up with 4, A to the 3rd, B to the 3rd, divided by 7, M, C to the 5th. And by the way, if some of your letters get switched around, if you had C 5th times M, you would be perfectly fine. All right? Number 10, notice that I have negative quantity 6 to the negative 2. This is like, and I want to show you something here. This is like saying negative 1 times 6 to the minus 2. And if you remember PEMDAS says that we do exponent before we do multiply. Okay? So it means we do this, the exponent of that, before we do that. Okay? So first of all, so I'm going to have my minus 1, and then the 6 to the minus 2 becomes 1 over 6 squared. Or in other words, this is negative 1 over 36. Notice that the negative is not part of what's being the exponent here. We take the opposite. Think of this sign as being opposite. So you figure out what this is, and then you find the opposite. If it's positive, you make it negative. If it's negative, you make it positive. All right, so let's get started on this one. Once again, notice right here I have a negative exponent. So because it's on top, I do the reciprocal and send it down. So I can write on the bottom 4a and change the minus to squared. Now down below here, I have 16, so that's going to leave alone down here. But here, I have ab to the minus 3, so that's going to go up. So I put ab and now positive 3, and then the c to the 6 stays the same. Okay, so let's expand ab to the third. That's going to be a to the third times b to the third. I have 16 times 4 here. Which is 64. Whoops, made a mistake there. Got ahead of myself there. This is 16, and then I got to square this. So this is 4 squared, a squared, and then c to the 6th. Okay? Now notice here, 4 squared is 16. So what I have here is 16 times 16. So when I end up here, I'm going to have a third, b third, over 256, a squared, c6. Now notice here this arrangement I have right here. I have an a third divided by a squared. If you remember the rule would say a cubed over a squared means keep the base and subtract the exponents, so you just get a. If you don't remember that rule, write it out. See, a cubed over a squared is 1, 2, 3 a's divided by 2 of them. And that's 1, and notice you're left with a. Okay? So our final answer here is a b cubed over 256 c to the 6. Okay. All right, let's get started here. Let's sort of set this up. I have 9. That's fine. X is fine. But my p to the minus 2 goes down. So I'm going to have p squared. Down here I have 3ax to the 5th. That's fine. But now I have a p to the 3rd. That one's going to go up. Okay? So a couple things to notice. So I go to the next one. I have 9 over x. And then down below here, I have 3 to the 5th, a to the 5th, x to the 5th. And then up here, I have p to the 3rd, p squared. Well, once again, p to the 3rd over p to that. Okay, let me just do a little bit of work over here. P to the 3rd divided by p squared is p to the 3 minus 2. When you divide them, you get that. So that's just p, which equals just 1p. And likewise over here, though, I have an x on top and an x to the 5. And notice if I follow my same rule, that's x to the 1 minus 5, which equals x to the minus 4, which is 1 over x to the 4. And if you look at this here, what we have, think about it this way. I have an x divided by 1, 2, 3, 4, 5. 1 cancels out. I have 1, and there's 4 of them on the bottom. That's 1 over x to the 4. So we can finalize this as 9 p over 3 to the 5th. 3 to the 5th is 243. 3 times 3 times 8, 5 times. And then I have the x to the 4th on the bottom. Okay? Now, one last thing. 9 goes into 3 to the 5th here 27 times. So my final answer then is p divided by 27 x to the 4th. A little complicated, but you have to remember back to your rules for exponents here. Here's your basic rules that you need to remember for exponents, by the way. I'll mark them up here. If I have two numbers that I multiply, like if I have a to the n times a to the m, the rule is keep the base and add the exponents. On the other hand, if I divide them, that's general rule is keep the base and subtract the exponents. And then one we haven't seen yet is if I take a power of a power like that, a to the n m times, that's the time that I multiply them there. That's your basic exponent rules that you need to understand exponents and powers. In the next section, we need to evaluate. Remember, the word evaluate has that word value in it. We're to give value to it. So if we put the value for A, we put in 2, and for B, minus 4. Now, the simplest way to do this is to first simplify the expression and then plug in. So notice I have a B to the minus 1. So this is going to become A to the 4th times 1 over B to the 1, or A4 over B. So now let's plug in our values. For A, I put in 2. So 2 to the 4th over minus 4. Okay? So 2 to the 4th, this is going to be 16 over minus 4. So my answer here should be 16 divided by 4 is 4, negative 4. All right? Now for the next one, notice I have 4 times a to the minus 3rd times b to the 0. Well, the 4 stays the same. Here we take the reciprocal and change it to positive. And here, any number to the 0 power is 1. So I end up with simply 4 over a cubed. And now we'll substitute. 4 over, and here we'll put in our 2 to the 3rd power. So this is 4 over 8, which equals 1/2. Problem 15 is like 13 and 14. It's just that we have A, B, and C. So first, let's simplify. Again, I have 3 times a cubed times b to the minus 3rd, and b to the minus 3rd, well, I'll leave it alone there. B to the minus 3rd times c squared. Of those, the only one that needs to be simplified is right here. So I end up writing 3 a cubed, and then this is going to be the reciprocal, and then positive, b cubed times c squared. So when we put them all back together, we have 3a cubed c squared divided by b cubed. And now we start plugging in the answers. So we have 3, and then we're going to have negative 4 to the 3rd power. And we're going to have c is 2, so we have 2 squared divided by our b is 3, and that's going to be to the 3rd power. Right. So let me just come up here and make it easier where we're going. So we have 3 minus 4 to the 3rd. A minus times a minus is a positive, but then you multiply by minus again and you get back to a negative. So 4 times 4 times 4 is 4 times 16, which is 64, so we have negative 64 here. And then 2 squared is 4, divided by 3 cubed, which is 27. Okay? So one simplification we can make here is 3 goes into 27 9 times. And so let's calculate 4 times 64. 64 times 4. So we're going to have here minus 256 divided by 9. And nothing reduces there, so we'll just leave our answer just like that. Minus 256 divided by 9. There are two ways to view number 16. It asks, a positive exponent shows repeated multiplication. What repeated operation does a negative exponent show? Well, the easiest way to see that, let me just pick a random number. I'll just pick, 5 to the minus 3. Okay? One way to think of that is simply 1 over 5 cubed. In other words, I'm going to divide it. That's repeated division. So positive is repeated multiplication, but this is repeated division. So if I have 5 to the minus 3, I'm going to divide by 5 3 times. The other way to think of this is to say, oh, that's my reciprocal to the positive third power, and that would be repeated multiplication by the reciprocal. But that's the same thing. You remember when you did fractions and they would say, okay, what's 3/4 divided by 2/3? And the first thing they would have you do if you had the old KFC was to say, keep this one and then flip this one and change it to multiply. Notice here that dividing by 2/3 was the same as multiplying by the reciprocal. So division is the same as multiplying by the reciprocal. So there's two ways to see it. Either way, it's a repeated, either you think of this as repeated dividing by the number or repeated multiplication by the reciprocal. They are the same thing. When I try to do an error analysis, sometimes the easiest thing to do is just to work it yourself and see how your example follows there. So let's start here with x to the n over a to the minus n b to the 0. Now you notice the first thing the person noticed was they said, oh, here's an a to the minus n, so that needs to go up. The reciprocal of that and change it to positive. So I have x to the n over a to the n over b to the 0. And that's exactly what they have too. So far we're so good. But then the next step is, look here at our b to the 0. What does b to the 0 equal? Any number to the 0 power is always 1. And here's our problem. Notice what they put down. They put a very common mistake. B to the 0 does not equal 0. It equals 1. So my final answer is just x to the n, a to the n. And his error is error. B to the 0 does not equal 0. B to the 0 equals 1. All right, I hope that helped you with your homework tonight. Have a great evening.